In this video I'll show you how to build your own dog ball launcher. Stay tuned. Hey guys, I'm back with another video. This time I made a ball launcher for my dog. The plan is to teach him to put in the ball by himself, but I don't think this is going to happen anytime soon. Let me show you how it works. So you or your dog put the ball into the funnel here, and there's a servo blocking the path and also a sensor here that detects the ball. And after a random time between 1 and 3 seconds, the ball releases and gets shut out. I also put in a motor controller to randomize the speed of the electromotors here, and every time the ball flies a different distance. In the next clip I show you how my dog plays with the machine. I also printed out different colored ears. Let me know in the comments below which one do you like best. I will give them away. Just send me an email which color do you like and I will send them out on a first come first served base. Here are some more clips of my dog playing with the machine, and after that I show you how to build your own. In this part I show you how to build your own ball launcher. The links to all the items you need are in the description below as always. A little disclaimer, the build process is a little bit non-linear because I changed the design during filming, but I did my best to put everything in the right order. But it's best to watch the video till the end before you start building it. I hope you enjoy. Thanks for watching. Bye bye. Okay, so in here is the 3D model I did before printing everything out. Let's start with the case. So you can see this is the case. On the bottom part, this is where the motor mount is mounted on. There's a little hole here, and here this is for the DC-DC converter. Those are the holes for the screws if you want to use them. And here goes the USB plug, PCB on and off switch, and this one is for the power connector. Then let's go to this one. This is where you mount the motors, like so. And here, this is the roller. Those are the smooth ones. Then next, this is where you mount the servo, and here goes the sensor. And on top, here goes the proximity sensor casing. And where's the funnel? The funnel goes like this. And then we have the exit ramp here. Like this. And that's all the stuff you need to print. And then we go on top like this. And last but not least, we need to get the ears. There you go. And this is the whole assembly. Okay, so here is the motor mount, and the next thing we need to do is put some threaded inserts here into the plastic so we can screw on the motor and also the other parts. And you need like a soldering iron. I have it set to 200C. And then you also need a plier. So you can put this onto the soldering iron. And then you need to wait till it's getting hot enough to melt through the plastic. So when it's flush with the plastic, you can just remove the soldering iron. And there you have it. Now we need to repeat this for this one, the other side, this and this. And I think 2 will be enough. Here and here, and here and here. And now you can use a M3 screw. The next thing we need to do is to assemble the little wheels that will accelerate the ball. And we need to put on this motor mount. But first we need to sand this a little bit so it's smoother. I have 240 grit sandpaper. So that should be enough. And then we take some M3 screws. And now we need to add the washer and the nut. So the only screws I had left were these little longer ones here, but I will cut them later with my Dremel tool. And now we need to do the same with the other wheel. And magic. So after some testing, I found out like the rolls I designed with the, they look like a gear, but when the ball is like full of saliva from the dog, it doesn't work. So what I'm testing now is like I printed them again, but with a smooth surface. And I will glue some non-slip tape. It's practically like sandpaper, but with sticky side on the back. And I already did this for one, and I put some rubbers around to help with the adhesion. And now let's do the other one. Now let's clean the surface with some alcohol. And like an X-Acto knife is very handy. Now let's add some rubbers to help with the adhesion. So we'll let them sit overnight, and tomorrow I will test if this works or not. Okay, so here's the problem with the wet ball. You can see I put it in water. Then it won't go through the rollers here because it's too wet and there's not enough friction. So I will change those with the ones we did, or I did yesterday. Okay, so now I changed the rollers here with the ones with the anti-slip tape. Let's try that again. Where's the ball? That looks good. Now this is pretty solid, so I don't think we need the other two screws here. Then we get the motor. Okay, now the two motors are mounted, and now we need to mount okay, just look that they are aligned. Now and then the ball comes in. And it will get shoot out. Okay, so the top half of the casing just finished printing. And at the end there was like this black little dot. I don't know why that happened. But let's remove the support and see how it looks like. Doesn't look really good, but I tried to print it like this way because printing it like this would be like 200 gram more filament and like 12 hours more on print time. But yeah, I think it's okay. Maybe next time I will print it the other way around. I also finished the little ears. They look really nice. Okay, let me clean this up and then I will attach them to the top part here. Okay, so here's the new bottom part of the casing, and as you can see it looks very good. And this is the first one. You can see that doesn't look very good, but in the inside it looks very good. So memo for me, next time I will print it the right way the first time so I don't have to do it twice. So it looks much better than before. Okay, and so here is the bottom part. It took forever to print. I think it was like 35 hours or something, but it looks great. Let's remove all the support material and have a look how it looks underneath. I hope it doesn't get like the same problems we had with the top part, but let's see. Okay, so I removed all the support material. It still doesn't look good. Let me zoom in a little bit. You can see it broke off like on all sides, but it's not that bad because it's on the underside and you can barely see it like when you look at it from an angle from above, like here. So I won't do anything about this one. I will just clean it up a little bit more. Here the holes for the power. You put in a little nut and then you screw in the plug like so. And this is the power button. And this is like the USB plug, so you can plug in from the outside and reprogram the Arduino, whatever you will use for your version. It goes in like this. And now let's see if the motor mount will fit. Like a glove. And I also forgot, I put in 2 screw holes here for the DC-DC converter. This one will convert like a 12 volt we get from here for the motors to 5 volts or 3 volts for the microcontroller. This will go here. And there's also a hole here to get the cable from one motor to the other side. And I also put in some holes for M8 screws. So if you need to bolt it down to something, you can just insert a nut here, like so. And then you can use a screw from down here. Or you can also use it the other way and get like a washer in here and then use a screw and screw it down to something from this side. So in here is the schematic how you need to wire everything to the Raspberry Pi Pico. This is the Raspberry Pi and the USB would be here. And the power connection goes like this. This is plus and this is ground. And this 5 volt goes also to this connector here to number 2 and goes also down here to the servo connection, also to number 2. And then you connect the servo connection to ground here on 1 and to the GPIO at 16 here. And this is the sensor connector. This is pretty easy. You just go like straight to the ports. Like SDA is 1 or GPIO 0. SCL is GPIO 1. Ground is ground and power comes from the GPIO 2. So you can turn on and turn off the sensor if you like. And that's about it. And here also you need to, the connection number 6 needs to go up here to GPIO 10. Because if you go straight, this is also ground. So that's pretty much it. Okay, so I finished soldering of the controller board. This is the Raspberry Pi Pico. And I used this prototype board and mounted some connections here and here and here. This is power, this is the servo, this is the sensor, and this is for the motor controller. I also made a cable for the motor controller. This will go in here. And then I will connect to the motor controller here. And this will go to 5 and ground. And this is the DC converter. It will get the 12 volts from the power adapter. and it will convert it to 5 volts so we can power the Raspberry Pi here. And this is the power connector, and this is the switch. So it will go in here and with another cable here like this, and then those go directly into the motor controller like so, and that's basically it. It's a very easy circuit. And I forgot to show you the USB cable I made. So this will connect to the Raspberry Pi like so, and this will go on the outside of the, or the inside of the casing, and then you can connect it from the outside, so you don't have to open the case every time you need to change the code. And in the background you can hear my dog. Okay, now let's assemble everything. Okay guys, so here is the code I used. It's not very complicated. So here you import like all the libraries you need. This one is a library for the sensor from Adafruit. And then you do like all the config here. Then the PWM for the motor controller. And here you define like the outputs for the motor directions. Here you give them the names. Here to the direction, that's like an output and not an input. And here, that's my values. That keeps the motors in the right direction for me. But maybe if you wire them differently, this one is different in your case. And then you initialize the I2 square bus here, and this is the sensor for the ball detection. This is the servo. Here you initialize the servo and set it to closed, so the ball doesn't go into the machine. It takes time, so this is a little bit of a pause so the servo can get into position. And this is a loop. When the servo detects the ball, then we create a random number between 40,000 and 64,000. That's the PWM values, and the steps are 2,000. If you go lower, then the motors don't have enough power to shoot out the ball. This is just for me. And then we also have like a random time between 0 and 3 seconds and in 1 second steps. If you don't want to do that, you can also just comment this out. Then we spin up the motors with the power we set up here. I put in a little pause here for half a second, so not both motors are starting at the same time, because that creates a lot of amperage. And then we'll give him 2 seconds to spin up fully, and then we release the ball. And then after 1 second we shut down the motors again, and the servo goes back to the closed position. So that's not much code, very easy. I think you can also do this in an Arduino. I wanted to work with the Raspberry Pi Pico this time, and it's much easier, I think, than in Arduino. Okay, first let's put in the DC-DC converter. Okay, that's good. So next thing we need to do is put in the USB connection. So here you can see the USB port. Let's see if we can connect and USB cable there. Where is it? Let's use the broken one here. And this looks very good. And this is the DC-DC converter. Let's put in the on-off switch. And the power adapter. Now we need to connect the cables here. There you go. Okay, so here is the elbow part. The servo goes in here, and I already mounted the sensor. Let me zoom in a little bit here. So you can see the cables come out here, and they will go inside like this. Let's get this zoom in here. Yes, I will put some hot glue in to fix the cable in place here, and same goes for the servo cable that comes out here, and then it will go down here. I'll also put 1 or 2 drops of hot glue in there to keep it there. Okay, that should be enough. It's also on the upper side of the elbow, so the ball doesn't get stuck in here. Okay, that looks good. Now let's mount the servo. So this is the servo, and here's the little arm. I will also put the file for this in the description below. And you may need to, let me zoom in a little bit, the holes in the little arm that comes with the servo, you need to drill the holes a little bit bigger, otherwise you may break them when you put in the screws. Okay, now let's mount the servo. First we need to put in the cable to the little hole here. It's a tight fit, you maybe need to sand it a little bit down. And then you put the servo. Let's get the cable like this. Then we need to screw down the servo. I created 2 holes here, so it's easier to screw it down. Okay, now we need to also hot glue the servo cable down. So This will go like this, and then the ball comes from this. Looks good. I need to remove a little bit here. Okay, I removed a little bit of the hot glue from the top. Much better. Okay, now we need to attach this to the motor mount. Okay. The other side as well. So, and that's the whole assembly. So motor controller goes here, and here goes the microcontroller. So we need to put one cable through here. It goes outside. Okay, my dog is really excited. So in the background you will hear him because he wants play with his new toy. Anyway, we need to connect the power here. This will go to the, where is it? Five volt is here, ground is here, and 12 volt is here. So this you need to control the speed. This will go like this. Okay, so here it is. It was a little bit hard to film, but this is the 5 volt plus. This is the common ground for the 12 volt, for the 5 volt, and for the DC converter. And this is plus 12. This goes also to the DC converter. And this one is connected here. It doesn't matter how you connect the motors because you can change the direction via the software later, so you don't have to put plus or minus, or it's not very important. Okay, so I connected everything to the controller board. That's the power. Then this is the cable for the motor controller. It goes through the hole here and comes off to the other side. Then this is the servo, and this is the sensor for the ball detection. And let's get this back down here. Make sure there's no cable stuck between the motor and the motor mount, the case and the motor mount. Okay, so we simulate the ball. Looks perfect. So this is the little case for the sensor, so it's protected. Put it like this. And then the funnel comes over here. But first let's mount the motor back to the casing. Because now the motor is back on the casing. Now let's mount the sensor casing and also the funnel. Okay, so I just put 2 screws in it. I think that's enough. You don't need like 4, but if you want you can put 4. And before you tighten everything down, make sure everything is aligned so it doesn't look like this, but like this. Then the last thing we need to do is put on the lid for the servo. Okay, and that's it. So the last thing we need to do is screw down the top part to the bottom part. And there are 4 screw holes here, here, and on the other side on the same side. And I will use this screw. The easiest way is to get it on the edge like this, and then and that's it. Now the bottom part is mounted and everything is looking good. I hope you enjoyed this little build. Thanks for watching. Bye bye.